Hi everyone. So this video I will talk about fundamental theorem of the calculus. For the fundamental theorem of calculus, there are actually two parts. One is integral and antiderivative, and the second one is about the evaluation theorem. Okay, so how do we talk about the fundamental theorem calculus? Part one is about integral and antiderivative and what that actually is. So it's saying that the part one is saying that if you have a function f, it's a continuous function over an interval a and b, and the function f is defined by by the antiderivative of ft. Then the derivative of this function f will be the original function. Okay, so let's prove that. So let's say you have a function, and that function is defined by ax f of t dt. Now our job is we want to show that at the end, f prime of x will equal to f of x. Okay, how come it's like that? So let's go ahead and take the derivative, f prime of x. But remember that we don't have a techniques how to take the derivative of this integral yet, right? But earlier in the chapter, we learned that in order to find the derivative without knowing any rule, we can actually using the limit, because the derivative, the function is actually the limit of h approaching to 0 of that function minus that function where the input is x plus h, and minus f of x, and then over x, right? So we can use that for this. And we know if we have f prime of x, if I apply the limit, I'm gonna have limit of x approaching to h. F of x plus h is mean I'm gonna replace all the place that I have x by x plus h. So I'm gonna have integral of a x plus h f of t dt. And then minus f of x is integral of a to x f of t dt. Okay, and then all over x. And when I get to this point, I don't know what to do, because I don't know how to find the integral from a to x plus h f of t dt, right? And what is the integral of this? Then how do I gonna apply the derivative? But remember, in the previous section 5.2, we know that the integral is actually help you to find the area. It's defined by the area under the curve. The integral is defined by the area under the curve. If this is my f of x, right? The integral is the area under the curve. So integral from a to b, f of x dx is the area under this curve. But we have the integral from a to x plus h, f of t dt. So it's mean, where's my x? My x is right here, somewhere right here. Okay, from a to x is this interval. And from a to x plus h is these pieces. Okay, this is x plus h. Okay, so the integral from a to x plus h is this big area right here. And the integral from a to x is the red area right here. Now, isn't that if I find the difference between this big area and that red region, I will have the area under the curve between x plus x, x to x plus h. So it's mean I'm gonna have the limit of x approaching to 0, instead of writing this, I can write at x to x plus h f of t dt. Okay, so is that possible? Yes, because from a to x plus h, this is the area under the curve of this region. Okay, and then from a to x is the area on the curve of this region. And when we take the big one, subtract the small one, I should get the area between them. So between x to x plus h under the curve f of x. So we're gonna have that. Okay. The x and the t here, it doesn't really matter. So I can also call this the f of t. It's fine. And these are just the label. These are just any number. All right. So the numerator become that. Okay. So now we have the region. We want to find the area of the region under the curve f of t from x to x plus h. How do we find the area? We know how to find the estimation, right? So if that area is like this, okay, this is x plus h, then we're gonna have the base. The base is gonna be h. And the height is what? The height, if I take any point between x plus h, then I'm gonna have the height will be f of c. Right? The height will be f of c. Then the area of that rectangle will be f of c times h. So I will have to replace that by limit of x approaching to 0, f of c times h over h. And now, can we cancel out the h? Yes, we can cancel out the h. And we turn out limit of h approaching to 0 is equal to f of c. And what f of c actually is, as x approaching to 0, as x approaching to 0, the difference between x and x plus h is really small, getting really small. X and x plus h. That forcing the c value is almost the x value. Okay, forcing the c value is just the x value. So instead of writing f of c, we can actually write f of x. Okay, and this will prove you that the derivative of the function, the integral of the function, is the original function. This is actually show you what? This is actually show you the concept that the derivative and the integral are inverse of each other. Okay, so if you take the derivative of the integral, you will get back the original curve. Which mean the derivative of the antiderivative f of x will be fx. And the derivative of the antiderivative from a to x f of t dt will be f of x. This is going to be the fundamental theorem of calculus part 1. Okay, fundamental theorem of calculus part 1. So if your x is not just a simple x, but is actually a function rather than x, then you're going to have chain rule. So f of p of x times p prime of x, okay? So we're going to apply that to some example, that apply the concept to the example below.